And we're back. Monday, still Mr. Citro here. 8.11. Okay, so we talked about air masses being large, immense bodies of air that have characteristics specific to the region in which they are created in. So if it's an air mass that's moving over the ocean, it tends to be maritime because it picks up a lot of that moisture. If it's an air mass over a continent, then it tends to be dry because there is a lack of moisture. Polar tends to come from higher altitudes or latitudes, meaning colder air, and tropical tends to come from near the equator, meaning warmer air. Now, fronts are when two air masses meet. And when they meet, they create a front. We have four major types of fronts: cold fronts, warm fronts, stationary fronts, and occluded fronts. Now, all of these fronts and frontal symbols are in your reference table. I'm going to pop really quick over to page 13. And if you see here, page 13. 1 second, buddy. Having a little internet issue here. There we go. Can you wait 1 second, buddy? There we are. If we pull up this weather symbol or map here, open image in new tab here. Oh, this guy. Weather symbols. On page 13, you notice you have all these weather symbols. We're going to focus on air masses and fronts. Okay, these are the two portions that we're focusing on down here. Now, really important when we're talking about fronts, if we notice we have symbols, triangles or half circles, and they point in the direction the front's moving. So if we were to look at these cold and warm fronts, they're both moving towards the top of the page. Let's go back to the notes here. I'm in the middle of a video. Can you wait 1 minute, please? You need to wait 1 minute, okay? So a cold front is when cold air moves into a region. The fronts are labeled based on the type of air that's moving. So cold fronts are cold air moving in. So if a cold front passes, we would expect it to become colder the next day. Warm fronts, warm air moves in. Now, in either case, warm air is always less dense, and less dense air tends to rise. So we see the less dense warm air being pushed up. And when that air is pushed up, it lowers its temperature, reaches the dew point, and we see condensation and cloud formation leading to rain. Warm air, as we mentioned, is very similar to a cold front. A warm front is just warm air that moves in. So we have a large body of warm air here. It's pushing in. And as that warm air pushes in, it forces the cold air up. As it does this, it condenses and we see rain. We also see warm, hot, humid weather after the front moves in because this is a higher temperature. Stationary fronts are when we have two fronts moving in opposite directions. And when this happens, they're pushing against each other, so they tend to hang around a lot longer. And we see longer periods of rain. So in this case, a cold front is moving to the right. And we can see it with the triangles that represents a cold front, and it's pointing to the right, meaning that's the direction it's moving. This warm front is moving to the left, and we can tell by these half circles moving to the left. That's your frontal symbol. And your last one is an occluded front. And that tends to be when a warm front is in between two cold fronts, and one of the cold fronts catches up to the other, pushing all the warm air that used to be in between it straight up. Here's a couple more pictures of what they look like on weather maps here. So again, we see a warm front on this top left picture. It's moving to the northeast. because those frontal symbols are pointing to the northeast. Now remember, low pressure systems rotate counterclockwise. And if we look at this, both of those fronts are moving counterclockwise. There are two really good videos I urge you to watch. They're very short, 4 minutes, on the difference between air masses and fronts. And that stuff should give you a great start. James, please stop with the mouse. Can you wait 1 minute? I am almost done. Cyclones and anticyclones are very large, strong storms. Cyclones are low pressure. We call them hurricanes. Anticyclones are high pressure. What we see is that lots of these low pressure systems are pushed from west to east, and that's because of those prevailing winds in the jet stream. And if we were to think back about air pressure, we said high pressure is clockwise and out. We tend to have good dry weather. Low pressure, counterclockwise and in. We see lots of bad weather and lots of rain. So that's 8.11 or 8.11 as a summary, focusing on fronts and how they're related to air masses and air pressure. Yes, Jane. You want a nice cup?